Okay, so let's take a closer look at the halogenation reaction that we covered. And we're just going to look again here. Here's my alkene. I'm going to react this with bromine, Br2. And so the mechanism doesn't change. The alkene attacks bromine, attacks here. You break the bromine-bromine bond. And so now you are here, right? And this bromine collapses on the plus charge. Remember, when you break the pi bond here, one of the carbons is going to be positive. All right, so here the bromine collapses down and you get your bromonium ion intermediate. Now here's where I notice like the most confusion. All right, so the bromonium ion intermediate is here. Both of these lines are wedged. That means that they're coming out of the paper or out of the screen. And because the bromonium ion is here now, the bromine that we lost here can come in and attack either from the top or from the bottom. Now let's look at what happens. Right, bromine can come from this side, right, or it could come from this side. All right, what I want you to understand is this: like, again, the fact that this reaction is always trans means this: bromine here will never attack from this side, right? It will never attack from the same side that the other bromine is on. It will only attack from this side, right? The opposite side, right? That's why the two bromines here in the product are trans. So let's look at a 3D depiction of this. So here's my 3D model of my bromonium ion. Here are my two carbons in blue. All right, I'll let it turn all the way around so you can see it. So here are my two carbons here in blue. Right, here's the bromine, and you can see right away that if anything tries to come from this face, it's going to be blocked by this bromine. All right, now let me stop this and let me put in two bromines. Right, here's one. I'm going to move this a little. And then here's the other that I'm going to move a little bit too. All right, so what we're saying is that this bromine can either come from here and attack carbon, or it can come from here. Let me turn it again so you can see. All right, again, this is my bromonium ion. Here's if the bromine were to approach from the top, right, it would encounter this bromine, which is pretty big. And just to show you, give you an idea of the size, let's put the electron clouds in. Right, so this is bromine. Look at the size of bromine, and then this is bromine also. Right, so one of these two approaches is going to be favored, and obviously because the product is always trans, it's going to be this approach where bromine comes in from this side. Okay, so that's how we're able to get the trans product, because the bromine in the bromonium ion is blocking one face, and so this bromine is not going to attack, or bromine is not going to attack from this direction, simply because, and let me pause it right there. Right, these two atoms are pretty big in relation to one another, and so the fact that this is a large atom, it does not want to come in from the same face that this bromine is, so it has to come from the opposite side. Let me turn the dots off. It has to come from the opposite side, which is from here. Right, so this is going to be the approach, and so I hope that helps to explain why we see the trans product, and I also hope it helps to clear up some of the issues that we were discussing when we were looking at this reaction in class. So, as always, if you have any questions, you can tweet, you can email, or you can drop by my office. Peace.